Hi Lana, welcome on board to this Q&A session on this particular topic, primary flight instruments. And in this session, we will be seeing about the question analysis, book reference, important concepts, and then we'll be solving topic-wise questions of this particular topic. Now let me switch on over to the blog containing the GATE Aerospace materials. So here I am on the Age of Aerospace blog and the GATE Aerospace tab. Now scrolling down to the flight mechanics portion, so here we have the flight mechanics portion. Now I'm dropping into the question analysis. So based on the question analysis of this particular topic, primary flight instruments, there were about two 1 mark questions which were asked in the year 2009 and 2013, and there was about a 2 mark question which was asked in the year 2007. Now this makes this topic somewhat moderately important. Now, dropping into the book reference for getting or gaining an better insight about this particular topic, you can read through the book Pilot's Handbook of Aeronautical Knowledge, the 2016 edition of it, and the particular chapter which deals with it is the eighth chapter, Flight Instruments. And this book is freely available with the Federal Aviation Administration's website, FAA. And now, regarding the important concepts, in this topic, there are instruments which are classified based on two types of systems. So either it must be pitot-static tube based or gyroscopic instrument. Now let's get solving. So here we have our first question, and this is a 1 mark question asked in GATE 2009. Uh, the question reads out as a conventional altimeter is a. So they are asking what is a conventional altimeter. So what is the basic composition of it? It must be either a pressure transducer, temperature transducer, density transducer, velocity transducer. Now, before answering this question, we need to know what is this transducer. So, transducer is nothing but a device which converts energy from one form to another form. So, taking an example, we can say that for the case of pressure transducer, this device detects the pressure and it transduces or converts the pressure energy into electrical energy or electrical signal, which can then be read out as an reading on the instrument. Now, regarding the altimeter in particular, altimeter is an instrument that measures the height of an aircraft above a given pressure level. So, basically, altimeter uses the static pressure or the pressure which is at that particular height to operate this instrument. So, here altimeter depends on pressure, so the answer must be pressure. So any other answers might be wrong. And for this purpose, let's see the purpose of other instruments too. So here we see that pressure transducer, the basic operation is like it converts the applied pressure into an electrical signal, and similarly temperature, density, and velocity transducers translates their properties, temperature, density, and velocity, into any other form of signal, and majorly it will be electrical signal, as most of the instruments are electronic. And now checking out the answer, we go in with the answer pressure transducer. Now the answer key also matches with that. So a conventional altimeter is a pressure transducer as it depends on the pressure. So here we see a typical diagram from the book Pilot's Handbook of Aeronautical Knowledge, 2016 edition, and we see different kinds of instruments here: speed indicator, vertical speed indicator, and altimeter. So we are focusing on altimeter, and here we can see two sources of operations are provided. So this is the pitot-static tube. So this is the pitot tube, and this is the static port. And there is an additional static port which is placed on the body of fuselage. So here we can see the connection that airspeed indicator obtains its source from both the pitot-static tube and the static tube. So this blue line is the static tube from the static port. And here we can see, as far as the altimeter is concerned, it only takes in source from static port. So here we can see there are two static ports. There are about two static ports. An alternate static source is used for redundancy purpose. So as we can see, it is only based on pressure obtained from the static port, which measures the static pressure. So it must be at pressure transducer. Now dropping into the second question. So this is an one mark question from asked in GATE 2013. So the question is, which one of the following flight instruments is used on an aircraft to determine its altitude in flight? So they are basically asking the instrument which measures altitude of an aircraft. So this is the major key point of the question. It isn't altitude, it is attitude. So there is a difference between altitude and altitude. Altitude means height. Attitude means orientation or position. So here you need to be careful about that. So attitude, regarding attitude, aircraft's attitude is the orientation of an aircraft with respect to horizon. What is this horizon? So let us consider a straight line. Consider this as a straight line in case. So if the aircraft is tilted or banking on some particular angle, we can see that the aircraft isn't straight or aligned with the horizon. Horizon is nothing but the datum plane or horizontal plane. Instead, it is inclined to some angle. So this is which the orientation means by. So here in aircraft we create an artificial horizon as we cannot always refer to land as aircraft flies above 3000 or 4000 meters from there seeing land is difficult as clouds may intercept. So here we the instrument uses an artificial horizon, which means we'll be seeing that what is this artificial horizon look like in the next slide. So before that, an artificial horizon is a gyroscopic instrument. The attitude indicator is a gyroscopic instrument or a fluid surface, typically one of mercury, is to provide the pilot of an aircraft with horizontal reference plane. So basically, this provides a horizontal reference plane for navigational purpose when natural horizon is obscured, means unclear or not available. Now, regarding the options, they are basically asking which instruments measures the altitude. So let's see the purpose of all these instruments. So here, vertical speed indicator is used to provide the rate of climb, that is the rate at which the aircraft is climbing, and altimeter provides the height or altitude of an object above fixed level. Artificial horizon is it provides a pilot with a horizontal reference plane, and turn bank indicator. It indicates the rate of turn. So basically, if we are concerned with altitude of an aircraft, it must be artificial horizon as no other options matches. So why are we doing this? Why are we seeing the reason for all these four options? For this particular question, we are only concerned with one option. But as far as GATE is concerned, there won't be any repeated questions. Instead, yeah, these questions are solved for getting a better understanding about this particular concept. And when we are knowing the reasons for other options, and the reason why they are wrong, you will be like learning three more questions in alternate. So that will be beneficial for you as well as me too. So here we go with the answer artificial horizon, and as the answer key matches with that. Now here this is the artificial horizon altitude indicator in actual diagram. So this particular line here which we see is the artificial horizon. So here we can see it is perfectly aligned with the aircraft. So this orange marker is the aircraft, and we can see if it is in level steady and level flight. So here we see the artificial horizon, and if it is in level and steady flight, we can see that it is perfectly matching with the artificial horizon. But when the aircraft is in some particular orientation, like here it is climbing with a left bank, and similarly it is straight climbing, that is you can see the difference. And similarly it is descending, then the airplane is getting below the horizon, and in similar actions. So this is the artificial horizon, and this is used to determine the attitude. Attitude is nothing but the orientation of the aircraft. Now dropping into the 2 mark question. So this is a 2 mark question asked in year 2007. Reading out the question, an airplane is flying at an altitude of 10 kilometers above the sea level. Outside air temperature and density at 10 kilometer altitudes are 223 Kelvin and 0.413 kilogram per meter cube respectively. The airspeed indicator of the airplane indicates a speed of 60 meter per second, and density of an air at sea level is 1.225 kilogram per meter cube, and the value of gas constant is given as 288 joules per kg Kelvin. The stagnation pressure is P naught measured by the pitot tube mounted on the wingtip of the airplane will be. So they are basically asking in for the stagnation pressure value, which is measured by the pitot tube. So they have already provided us with the four options, so the answer must be within one. So writing down the given, they are saying that the aircraft is flying at 10 kilometers altitude, which means 10,000 meters, and the temperature at that particular altitude is 223 Kelvin, and the density is provided. Now here we can see that they have provided some kind of speed or velocity, but they say that it is shown by the airspeed indicator. So airspeed indicator are also known as ASI, basically provides us with the IAS or indicated airspeed. So it is in calibrated for any other purpose. Indicated airspeed takes in account for the density at sea level. So this density at sea level is 1.225 kilogram per meter cube. For further reference, we will use some other density. Now here they are asking in for stagnation pressure, and they have provided the values for sea level conditions and gas constant. Now the formula for stagnation pressure P naught is equal to P plus half rho V square. How did we arrive this formula? So this is nothing but the Bernoulli's equation. Stagnation pressure is nothing but the pressure which is built up when the flow is isentropically brought to zero velocity or decelerated to zero velocity. So in a similar case, when we substitute the velocity to be zero, so this whole term on the left hand side cancels out, and we will be remaining with P naught. So this P naught is the stagnation pressure. So for this, we need to find the stagnation pressure. And here about this, we have two different unknowns. We don't know the pressure at that altitude, as only temperature and density is given, and the velocity is given in IAS or indicated airspeed terms. And what we require is the true airspeed or the airspeed at that particular altitude, 10 kilometers. So here solving in one by one. First, let me solve the value for true airspeed. We know that when relating the true airspeed and indicated airspeed by Bernoulli's equation, we can relate the dynamic pressure terms of these two airspeeds. So here, when we rearrange this equation for finding out the VTAs, we can see that the equation will be rearranged to such value, and the particular point to be noted is that here density rho means the density at 10 kilometers, and rho SL means the density at sea level. So here we'll be obtaining this kind of equation as half and half gets cancelled out, and other terms are rearranged. So okay, now substituting in the values, as we know the VIA is as 60 and density as sea level. So here we will be obtaining the true airspeed as 103.334 meter per second. Now solving it for the next unknown value, the pressure at that altitude, we know from the equation of state P is equal to rho RT. So here as we are concerned with the values at that particular altitude, now I am taking all the values at that altitude. So for PA, I will be substituting rho A R gas constant times TA. So A means altitude. So here we know the value of density at that particular altitude and temperature at that particular altitude. So the density is given as 0.413 and gas constant is 288. So here you need to focus that it is 288 and not 287. If you substitute in 287, then the answer may be erroneous here, and temperature is provided as 223 Kelvin. Now multiplying all these terms, we will be obtaining the value 26524.512 pascals. And now we have obtained two unknowns. So from this we can easily solve in for the stagnation pressure. So here substituting in the value for pressure at that altitude in pascals plus half rho, which is provided already, and V here means VTAS. So at that particular altitude is 103.334 square. So we will be basically obtaining the value as 28729.512 pascals. Now, relating to the answers, we can see that the point value is different, but here the unit is also different. So, in Newton per meter square, you can also write this as by translating the point value here as 2.87 times 10 to the power 4 Newton per meter square. So, this must be the right answer. So, checking out the answer key, we can see that the answer matches. So, this must be the right answer. For better clarification on true airspeed and indicated airspeed, you can always watch the respective video. For basic understanding, just remember that true airspeed is the airspeed corrected for the density at that altitude, and indicated airspeed basically takes in the sea level density as it is in calibrated. That's it for this session. Let's crack GATE Aerospace.